Okay, in the last session,
Yes.
last session we saw that we entered we placed one connection and then we entered some parameters in that connection. Some parameters we filled in and then we modified that connection. Like I have shown some basic, like this is plate, some basic. We have not gone in the stiffener yet, but some basic what is visible to you now is the connection plate, bolts. So we added the bolt standard size, tolerance, and the type of bolt here. Then we can change the spacing also here. If you want to change the spacing, we can change it from here. Quantity, if you want to change the quantity, you can change the quantity from here. Like say this is 5 bolts. If we need a 6 bolt, we can add here 6 quantity. And if I modify it here, we'll see it will get modified by 6 quantity. So this will increase. You see, this is increase. But what happened? It is going below the flange. So I can reduce it to 4 numbers. So now number of bolt is reduced 4. Right? Say this is 6. And I can decrease the spacing. So internal spacing is 75. Then or we can make it as 60. 60 or 50. Yeah. So now you can see it is accommodated now properly. Say if I want to change this to 24 diode bolt is more, then we can reduce the number of bolt by 4 and we can increase the spacing by 75, right? So that way we can modify this connection. Whatever condition we require, we can modify it like this. Understood? No? So if edge distance is there, you want to increase the edge distance by 40, you can do that here. So your edge distance is now modified. You want it as 50. Then it will automatically adjust the edge distance. Okay. So everything will get adjusted automatically.
Okay.
Now here what we can do one thing by default it is from top, middle, below. Now here if you can see now this is here it is less, here it is more spacing.
Yeah.
Yes, this is less more because it is from top. So by default there is some value of Tekla which is getting here. So and that is by default is top here. So always it will be from top. So if I am entering some distance here, say 50, right? And then I will modify it. You can see it is going from top. Reference is from top. Say this is 60, and I modify it. Or I will keep 70. Right? Now it is moving from top. From top, it is taking the distance 80. So this is reference is from top. So if I'm keeping it as middle, then I'll keep this as remove this value, and it will be from middle, centered, beam center, and below. Below we are not keeping below. We are not keeping below. Always it will be from top or middle.
Top one.
Top and middle. Now normally we'll be keeping default. When we are modeling in Tekla, we will keep it default. So default is top. Right? So some distance will be there. So always you will see standard will be like this, some distance from top. So first bolt will be locked from top. And then you will be having this number of rows of bolt. And the standard will be like this. Right? So you have to follow the standard. So you will see the connection is also developed according to the standard that you are following. Connection standard. So connection standard. This is according to the connection standard. So whatever parameter you are seeing here, these are according to the connection standard which we have. Okay. Another thing we missed, that is okay. One more thing is, now we saw plate, we saw bolt part. Here there is one more addition, new addition, that is bolt rotation. Now here you will see this is head. I will open another view. I will open a plan. No, when the plate is one thing, then bolt is there, and then we have weld. Then we have weld here. So when we are adding weld here, we need to add a weld here. So you can see this picture is there where they have shown how, where and how we have to add the weld. And what are the type? So type will be like this. This is a type of weld. Different type of weld are there in type, listed in type. And numbers you will be referring from this chart. Okay. This size. This is now there are in one there are two, 1 and 2. So near side and far side, you can see. Near side and far side. Whenever weld is there, it will be having the near side and far side option, right? So what is that near side and far side? I'm showing you here in the sketch. So, all I wanted was just to this is the example. I'll just show you the weld example. Welding example. So, And just show generalized welding symbol. You might be already aware of the welding symbol, you know. You might have seen it in some project. This is what welding symbol looks like. Something like this. Now this one is near side. One is far side. This is called symbol, or we call it as a type. Type of symbol. This one is all around. And this is called pointers. Pointer arrow. So, so pointer is always near side. Okay, so pointer will be always even near side. So near side is so I've shown wrong symbol. Near side is actually down side, and far side will be the upper one. The wrong symbol. So near side is this one, and far side is that one. So this is called far side. This is called type, and here we call it as leg. Leg will be like 6 mm, for example. And here will be length. Length at space like 100. length 100, height 500. So this is like just example. Okay, far side and near side, and then there will be one more part. In this. This we call it as tail. Right, this is the tail. And in tail, we will be adding some text or something like that. Say text will be keyword or sorry, something like this. In this example, you can add any kind of text. So this is a general symbol. There is one more part for this, that is called um, this is called the sight weld, or we call it as a field weld. Field weld. So this symbol stands for the field weld. This flag. Hmm? So this is like a just a general symbol, generalized symbol, welding generalized symbol. What you're seeing here, you just keep in mind. Here there is a type, so different kind of types are there. So when I go into type, you can see there are different kind of types are there. These are available types in Tekla. And also when you go on Google, you will find some more types are there, different combinations will be there of welding. And then here there will be a finish. This contour means this contouring is the finish. How which type of finish you want. And then here, this is also a different finish. Grading, grinding, okay, machining, that kind of thing is there here. This is like for the groove weld. For bevel weld, we are using these options for this kind of weld. This is bevel weld. So there will be different options we are using: root face, throat, opening, all that things. And then angle is there. And here that option is there for all round weld. We just saw in the symbol all round weld. So it is there here. And sight weld is there here. This is the flag for sight weld. This one, field weld. Field or sight, that is one and the same. So you can call it as sight weld also. The field and sight is one and the same. So just example. So here the weld actually will be seen here. Okay, this is the sight weld. So if you want to activate that, you have to select here. If you want to activate the all round, you can select it here. It will be activated from here. Right? Then length and pitch. So length and pitch here. This one is here, length and pitch, right? And reference text. So that is the tail part. In tail part, we can add the reference text like typical. If it is typical, if it is three sides, then we can give that as per the requirement. Right? Maybe as per the requirement. As per the design requirement, right? So that's what we are adding here. Now we'll add the weld here now. Architecture. So here weld number, you can see this arrow for 5. So 5 number is what weld we have to give now here. Okay? In here connection. Because our plate is here. We don't have a stiffener here. So our plate is 5 number. So 5 number weld is this one. Right. So building 8. Or whatever the size is, it is given in the design. That size we have to provide. Okay. So now we saw the 3 parts: plate, bolt, and weld. We are adding. Once all this is set, then we will save that connection here. But here you can save that connection, like SH. You can give any name, whatever you want. That I'll give here FSC shear connection, SC for shear connection. That column to beam CG that 001. So this code, normally I will follow the code. Some code will be there. So what I'm doing, this will be easy for tracking. I will always give a code here like this, save as. And once you save it, it will be there in your library. This is now saved in the library. So whenever I need that connection, particular connection, I can go in the library and load it. So I'll go to get those features. Okay. So when I want to apply it to some other location, I just need to load that connection. When I want to apply, I will just double click here, and then load this and apply. Okay. And then you have to apply it on the in the model. Primary part, secondary part. So that way, this way we will be applying connection, right? In complete model. Right? And this connection now I have saved. So when I go here, when I go in the open model folder here, when I go in attributes, I will see the connection is saved here. You can see SCCB001. J146 is the code. Right? J146 is the code 146. Okay. So this is the reference. Right? Now I have the connection. Okay, this I can copy it. If I want to copy it in another folder or another model, I can go to that model in attributes and then just say paste. So when I open this model, I will have this connection ready. I don't have to work again, right? So this will automatically, yeah. So normally we are doing like this. We'll create a library of one project. If you want that same thing in another project, then you can just copy that connection directly. No need to work again and again on the connections, right? Because yes, connections will be same normally. Number of bond, standard, mostly it will be same. Like for Indian standard or for UK standard, connections will be same. So one time only we will be preparing those connection and then we will be copying to different project. Or if you are working on some big project, so one model, if you are preparing one connection, that connection can be used for other models as well. So if you have say 50 models in one project and you are preparing connections in one model, then you can use those connections in other model also. Or their standard, whatever standard is there, you can just copy this standard in other models wherever you want. Once this is a library, attributes is the library of Tekla, right? So if you want to copy, you can go in the model folder, attributes folder, and then copy whatever you want, you can copy it from there and just copy it in the another model attribute folder. So attribute folder is the location where all standard connection, standard grid, whatever connections you are preparing, customizing, so whatever you are preparing, all will be in that folder, saved in that folder. So whenever you need it for another project, you can copy it directly instead of uh, giving your time every time you have to prepare a new connection. It will take some time. No? So instead of that, you can directly copy it. No? It will save your time, right? So our main intention will be to save time. So how you will be saving time? Like if you have a library, you will just copy it in another model and start applying the connections, right? You understood? No?
Yes, sir.
This is like a simple connection. Now we'll go for some different connection on the other end. So on the other end, we'll try to add some different connection. End plate. We'll try out end plate connection here. 144 end plate. I'll click here. Then click the column, main part, and then secondary part. B. Yeah, so now I have this end plate connection in place like this. Now I'll go to the properties. You go to the properties, and properties you will see this end plate connection is there now. Now slightly it will be different from the share tab, but mostly all things will be same. Basic things will be same, like plate. Here also you have to enter the thickness, position number, material grade, plate. Same what we did for the shear connection. In bolt, when I come in the bolt, this is also same, but this only here, this type is different. But the basic is same. Like you have to enter the spacing here, number of bolt here. This is from top, right? So this is similar to the shear connection. So bolt part will be same. This part will be same in all the connections. Plate also this will be similar in all the connections. You have to enter in this way only. So when I enter the end plate, same thing. P1. This will be plate. Oh, sorry. This is material. No? This is name. Materials should be here. We should go here in 355 and then modify. Okay, now you can see the plate is modified. Bolt also similarly we can modify it to mm. Yes, site modify and then change the quantity. It should be 75. Maybe middle like this. If it has 5 also. 5 is also okay. So it's 5 and then 150. You have to check the spacing also. This spacing, center to center distance also. It should be sufficient enough. And then you will have to modify it. Or you can keep it as per the standard requirement. Once it is done, everything is done. And we need to go to welding also here. Now in welding also you will see similar is there, but the sketch is different because this is different type of connection. So here only there will be difference. So only thing you have to look at the numbers here. Number 3. So we have to go for the number 3 weld. Number 3 weld we want to add here. And size will be here. Here no need anything. So just remove that. Keep it blank. Like this. Keep it like this. And then this is complete. So I will just now save it. This is also shear connection and EP because it's end plate and 001. Right? I will just say save it. And this is now will be added to the library. You can go and see here in the attributes. You see it is added to the library now. Right? So whatever we are saving, it will be added to the library. So all connections we can copy it from the library directly, right? We'll move on to different connections. Now this was first was a little bit simple. This was also was a bit simple connection. Now we'll go for a different connection, that is clip angle. This is little difficult connection. So why it is difficult? We'll just see. Just the clip angle. Application is same. Primary part, secondary part, finish. Only part is when you go inside the connection, that is a tricky part there. Right? So playing with that is a little bit difficult, right? Only thing you will have to play with this stuff, right? All this is same, like this is picture will be similar thing. Primary part, secondary part is there. Even when you go in the end plate, you will have same thing. The first picture will be showing you primary and secondary part, how you have to pick. So in connections, you will be having the first tab, which will tell you something about the connection, like how you have to pick the connection, primary. What is primary and what is secondary, it is showing here, right? So whenever you are going in any connection, it will communicate with you, like from picture, how you will come to know that in picture there will be a communication given, like primary part is this one and secondary part is this one. So this way they are communicating with the users. So users will understand by looking at this picture, they will understand that this is primary part, this is secondary part, right?
Oh.
And they will be able to apply the connection. So in order to avoid the confusion, they have given it in a very simple way so that user will be able to understand. Now this is little bit complex because this is angle connection, right? Little bit complicated because angle connection is there. So we have to play with different sizes of angle, and then bolting is also in a different way. Here there is no there are two areas where we have to bolt. One is here, one is here. So when I go in the bolt, you will see a different interface here for bolt. You can see there is double. This angle, this part also is getting bolted sometimes. Sometimes this part will be getting bolted, right? So it will depend on your design, connection design, which part you have to bolt. And this is the option where you can choose which part of the angle you have to bolt to main part or secondary part. That you can decide from here. See, here it is given. Like here it is getting bolted with the secondary. Here both side, secondary and primary, bolting with the second picture will show you bolting with the primary and welded with the secondary. So most of the case we'll be having this kind of connection where angle will be welded to the beam and bolted to the column. So this is the most common case in clip angle connection, right? Welded to secondary beam and bolted to the primary column, right?
Hmm.
This you have to keep in mind. So when you are working with clip angle, this thing is very important. And secondary bolt. Secondary means this one, which is bolted to the beam. They are called secondary bolt. Which is bolted to the column, that is called primary bolt. Okay. So primary is this one, secondary is this one. Understood? You understood, no? This one. Now, when I say, I'll reverse it now. I'll weld it to column and bolt it to beam. So now we will see different thing happening in the connection. Like that.
Wow. Everything.
No, it will not change. It should change it, you know. If I am changing it to welded, bolted, this should, okay, sorry, this is already the case. So this is already there. We'll change it to this one. Oh, sorry, not this one. This one, where secondary beam is welded and bolt is there. So now we will modify it. It should change now, yeah. Right. So bolt is now on the main with the column, and welding is with the beam. You understood this? This portion. If I want it to welded with the secondary beam, I have to go for this option. Then the bolt will be bolted with the secondary beam, right?
Stand up. Sit here. Just wake up.
Okay, but most of the time we'll be keeping like
Sit
this.
here. Please.
This is common practice is welding here and field there. It's the most common thing. And for number of bolt and all those things, same. This is same like end plate and shear connection what we just saw.
अरे वरती बसता.
So,
तन्वी.
minimum tolerance. This is like a general assumption, or generally we are following 2 mm tolerance for all the bolts. Okay. General criteria, threading material, yes. Now here you will see there is no option for site and shop bolt here, but it is there. It is there here. It is shifted now here. Okay, it is there here. Okay,
वरती बस.
site and shop. So this site bolt is here. So I have to tell modify and
Please
keep it
work.
as side bolt. There is also a welding option here because we have welded the angle to beam. So
Thank
2 number is for this 2 number weld is for the
Bus.
welded connection. So whichever number is there, only in that number you have to add the weld. You should not add the weld anywhere else. And other things you have to keep it blank like this. I'll show you. Okay. Modify. Okay, so this is how weld should be applied. And then once this is done, now again we have not applied the angles. Say we want to change the angle size. This is default angle because we haven't entered anything here. So we'll just add some angle.